thinking then is that you want to be on the diagonal. You want to be on this diagonal here. If you're off the diagonal, if you're say up here or you're down here, that's an inefficient way to run your business. If you make high volumes of just a few things, you're going to want to set up business as a flow shop. If you make lots of different things but at fairly low volume, you want to set up business as a job shop. If you're somewhere in between in terms of your product characteristics, then you're going to want to run a batch flow operation. And I should note that again that the text doesn't actually use this term product process matrix, so I do have an illustration that looks sort of like this, with the exception that the flow shop is broken out into two different types of flow shops. So the basic lesson in here is that we need to match the process to the product, or the types of products that we want to produce. Whether we're going to have an assembly line or a job shop really depends upon what we're making and the nature of those products. So that's the first step in facility layout, is trying to figure out what type of processes we need, which really depends upon the types of product that we're making and who we're selling those products to. Now, once we do that, then we can worry about coming up with a good layout for the type of process that we have. There's going to be two types of layouts that we're concerned with. They're called the process layouts and product layouts. Now, in both types of layouts, what we'd like to do is minimize movement, okay, of both people and material, because movement takes time and time is money. We also want to maximize the utilization of people and the machines, because again, if people are not being utilized and machines are not being utilized, that costs money as well. So we want to accomplish those two things, but which one we need to focus on sort of depends upon the type of layout that is appropriate for our business. If we have a process layout, which is what is appropriate for a job shop operation or a batch flow operation, what we're going to do is group workers and machines by processes to form what we call work centers. Right? A work center is generally, in the sense we're using it here, a group of similar workers and or machines who can perform a certain type of task. And here's a picture, sort of a floor plan of a process layout right here. So I've got machines represented here, M2, that's one type of machine, M1, another machine, M3, so forth, a different type of machine. So these could be milling machines for cutting metal, these could be grinding machines for grinding metal, these could be turning machines, lathes, this could be a paint area, okay? So we've got all the similar types of machines. Each similar group of machines has its own area, and that's a work center, that's a work center, that's a work center, and that's a work center. And what we do, because we have high product variety, is we can simply route each individual product or batch of products from the first work center where it needs an operation to the next work center where it needs an operation, to the one after that, and the one after that, and you go back and forth a couple times if need be. So we can see how the jumbled flow could easily move between these different work centers in a process layout. In the product layout, which is very different, we're not going to have work centers in the same sense. We're going to have production lines. So here's an example of a product layout that has 1, 2, 3 production lines, and you see here that the individual machines are grouped not by the type of process, which is where we get the name for the process layout, but they're grouped by the sequence of steps necessary to make the product. Okay? So for this production line right here, the first step necessary to make the product requires machine M2, the second step machine M1, the third step machine M3, and so forth. And we have a different production line here with a different sequence of steps, and a different production line here with a different sequence of steps. Right? So we're grouping the workers and the machines by the product, not by the process. Process layout groups by process, product layout groups by product. Here, instead of work centers, we talk about workstations. So here's the first workstation on this line, here's a second workstation on this line, and so forth. This is the classic assembly line. You think of the movies where you see an automobile assembly line. That's a line dedicated to making basically one type of product. So each of these types of layouts, which is each geared towards a different type of process, which themselves are geared towards different types of products, each of these different types of layouts has a different primary concern, I guess I should say, because we're interested in both maximizing utilization and in minimizing movements in both types of layouts. But for each one of these layouts, one of those objectives is really easy and is pretty much done by going with that type of layout, whereas the other objective is much more difficult, and that becomes our focus. So for example, in the process layout, we grouped the machines and people by processes. It's relatively easy, if you've got cross-trained workers, to move people back and forth between the work centers as your demand for work in different work centers it changes over time. So we can relatively easily adjust the capacity of each work center. So we can also add and remove machines after our initial layout. So maximizing utilization of the machines and workers is not going to be our primary concern during the initial layout. What is hard to do, on the other hand, after the initial layout is to move entire work centers around. Okay? So what we want to focus on in the initial layout is minimizing movement, minimizing transportation cost. And by transportation cost, I mean the cost of moving parts and people from one work center to the next. So what that means is the work centers that I think are going to have the most material and human flow between them need to be located the closest together. So that's going to be our primary focus when we're coming up with a process layout, which is what we're going to do if we think we should lay out a job shop or a batch flow operation. For the product layouts, which are again appropriate for flow shops, either repetitive operations or continuous flow operations, and we have the exact opposite situation. Minimizing movement is not going to be a big concern. We're minimizing movement by the very fact that we're setting up dedicated production lines for each of the products or product families that we produce. They're pretty hard to get the movement down to a shorter distance between steps of the operations than it is in an assembly line. That's why people like assembly line if you know what you're going to be making, if you have standardized high volume products, because you can't really minimize that distance between operations anymore. So that's not going to be a major concern of our initial layout, because that's going to happen just by virtue of going with a product layout. What we need to focus on the other hand, is maximizing utilization. Because once we have these production lines set up, and again here I've got a real simple example with 4 stages, but think of like an auto assembly line with hundreds of stages. It's much harder to shift workers, add and remove machines at each line after that initial layout. So what we're going to pay a lot of attention to in the initial layout is maximizing utilization of the workers and machines on each line. So again, it's the exact opposite of the process layout. Just by going with a product layout, we're going to be minimizing movement. So what we're going to focus on is maximizing machine and worker utilization. So what we'll do now is want to follow on with the next video, and I'll first take a look at some tools for process layouts, and then in the video after that take a look at some tools for product layouts.